Hello everyone. Today we're going to continue looking at the code, doing the code review of the previous session. We believe we left off at the scriptable object class that emulates an enum with additional behavior. Last time I was talking about how the serialization callback receiver, which clears the runtime behaviors after deserialization, is probably used to make sure that this properly resets when entering play mode. And I have, since I've done some tests, I found out that yes, indeed, the non-serialized attribute has an effect on. In fact, what happens is that when you enter play mode, Unity actually performs a hot reload, which means that all your existing assets, all your existing code files, assets, mono behaviors, prefabs, serialized objects, scriptable objects, they all get duplicated, and then the old ones get serialized, and then the serialized values get fed into the duplicated instances, and get deserialized into those. And so what Unity does under the hood is a hot reload, which means that Unity serializes and stores all variables in all loaded scripts, and then it restores them to their original. It creates a copy, and then it restores those copies to the original pre-serialized values, including private variables, as long as they otherwise fulfill the requirements for serialization. So even if a private variable doesn't have a serialized field attribute, Unity would still try to serialize it and inject the serialized values into the copy that actually runs in play mode. So various ways to prevent this from happening, because it's definitely bad for scriptable objects. You don't want any fields like this one, which is like, it's a cache, right? It's a cache of something you pre-computed or you computed at runtime, and you don't want that to leak into the next play mode. So various ways to prevent that are basically you make the field not serializable. So normally only public fields or those that have a serialized field attribute get serialized, but we know now that also private fields get serialized if they are not static, they are not const, they are not read-only, and it's of primitive data type, enum type, fixed size buffer, like an array, built-in types, vector, matrix, whatever, right? Structs with the serializable attribute, anything that derives from object, classes that are serializable, arrays, lists. So Unity famously doesn't serialize dictionaries and hash sets, but it does serialize lists, and that's what we have here. And so last time I already suggested to make this read-only, and by doing so, I've already destroyed the serialization of it. I don't know why Unity doesn't serialize lists if they are marked read-only, because it doesn't make sense to me, right? Like if you have an int that is marked read-only, then you can't change it because it's read-only. But a list that's read-only, you don't want to change the list itself. You don't want to reassign the list. You just want to fill it up with values, right? And you can still absolutely do that even if it's read only. So I don't know exactly what's going on there with Unity, why it decides to just not serialize read only fields, but okay, that's what it does. So by making it read only, I already fixed the problem that we were trying, the original author was trying to solve here by 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 clearing it in on after deserialize. So all of this can go away, which is great. Right? It's significantly easier now. No funky stuff going on that is there to deal with quirks of the Unity engine. That said, I would even go a step further and put a non-serialized attribute on it, because that way you're making it double clear, right? the fact that this list is read only has more to do with, well, we don't want anyone to reassign it. We don't want any null checks to happen. We don't do this to prevent serialization. Serialization should be a different concern, and the way we deal with serialization is we slap on a serialized field or a non-serialized attribute on it. So I would recommend that when you write Unity code, explicitly tag all your private fields either serialized or non-serialized. That way, it's very clear what you want, and Unity will simply do the right thing, right? We'll leave the field alone, even for things like hot reloading. And hot reloading is, if you've ever tried hot reloading in editor, which is, let me think, where is that actually? Here, script changes while playing, right? If you make, so hot reloading, the original idea was, okay, Unity is running, you're making a change to your code, you're writing something, right? And then you save that, and Unity will right away recompile and continue playing. That's the default setting, I believe. And so what it does is, well, it recompiles your code. Now there's a new DLL, and the old code is running. The game is running on the old DLL. So what it does is it serializes everything that is in the game right now, like on screen, in the scene. It throws away the old DLL, it loads the new DLL, and it tries to deserialize everything into instances of the same classes from the new DLL. And hopefully you haven't deleted any of the classes, right? Because that would create problems. But because Unity cannot serialize everything, let alone serialize everything perfectly, hot reloading is just remarkably broken in various ways, right? Some of your stuff survives, some fields survive, and then other fields like dictionaries and hash sets don't survive, and you end up in this completely weird broken state where things go. You're basically in like undefined behavior territory, because all your assertions about, or invariants about what state the code should be possible to be in are broken. So hot reloading bad. That's why I'm using recompile after finish playing. I don't want. I mean, the only two sensible options are stop playing and recompile. So whenever you make a code change and you go back to Unity, it's just like hits the stop button and stops play mode and then recompiles, which is really annoying to me because I often find myself in a situation where I just want to look something up in play mode. There's like some script over here that has some values, and I'm going through the code. I'm going back and forth and making changes to the code, and I have to be super careful that I don't save the code, because otherwise Unity will just like, okay, hard stop and exit play mode, and I'm losing all the game objects that are only available at runtime, right? So the setting that I find that most useful is recompile after finish playing. So it doesn't do anything unless you explicitly tell it to stop, and then it recompiles, and there's no hot reloading. And this is also the reason why my Unity has a slight red tint when it's in play mode, so that I don't forget to turn it off, right? Because otherwise I might be wondering, why are my things not showing up? I've added fields to a scriptable object. Why is this list still not being updated? So the tint, I think, is under colors or something. There's a play mode tint somewhere. I forgot where it is. Ah, here, play mode tint, right there. Tangent. Anyway, let's go back to the code. So this is a bit easier now, right? And this list needs to be a list because we are actually dynamically adding and removing things from it. Yeah. Okay. Before I continue reading about what this class is doing, I'll try to get a broader understanding of the overall architecture and where this class is used. So let's have a look. These were the behavior types. They had prefabs associated with them. And when we place an entity in the game, it uses that to spawn the entity's behavior. We came from entity instance, I believe. Right. Entity instance. Oh, so this is a funny one, just as we're talking about serialized and non-serialized. This doesn't make too much sense. I mean, it's not like the end of the world or anything. Oh, this is interesting. It's a serialized field, but we're also doing runtime adding and removing to it. Why is it a serialized field? There's a conflict of interest here, right? If you have a serialized field, you want its value being set by the inspector at prefab building time, and it's a pre-configuration thing where you fill in your values in the inspector, and then at runtime you only read from those values. But what I'm seeing here is that this behaviors list is being used at runtime to attach or detach behaviors, which indeed gets invoked. And I'm not so sure if it ever gets used as a serialized field, if it ever is non-empty in Unity. But let's find that out. Okay, let's find that out first. And if it also is used in Unity, then there's a conflict of ownership over this field, because Unity wants to put stuff in it, but at runtime you also want to put stuff in it. Like who wins? Entity. Like who's in charge of this field? I guess it would be on prefabs. So here's an entity instance. This list is empty. In order to find all the prefabs that are using the entity instance script, I've installed the quick search plugin from the Unity registry, and it allows me to just search. So if I search for entity instance, which is the name of the class, only that class comes up. But if I search for the type entity instance, it finds me all the prefabs that contain that type. So it finds the empty entity that we just were looking at, and then the other one is the one below, which makes sense. Those two and nothing else. So and in both of these, the list of behaviors is empty, which makes this easier to fix, right? I would have expected this to be either a serialized field or a dynamic field. So it looks to me like this is meant to be a non-serialized field. And then again, let's make it read only. And the rest is good. We're good here. Okay. So an entity instance can have behaviors, and we can ask it whether it has a behavior based on this SO enum that we pass in. Go over the behaviors. Do we actually need an I here? No. Okay. So I'm really going over this code with a fine tooth comb, but behavior instance. Okay, couple things. This is a for loop with an explicit index, but the explicit index is not used except to, get the element out of the list. And and we can just use for each for that. And it used to be the case that for each allocated garbage, it used to be the case that for each wasn't as performant. It used to be the case that for stupid reasons, stupid technical reasons, in Unity, this was better. This was over a for each loop. That is no longer the case. That is absolutely no longer the case. Nowadays, the actual code that the compiler generates is exactly the same when you use a for each loop, and you get rid of a couple of points where you could make mistakes in your code, right? Like you can, this could be a typo here, or it could be more than one, or you forget to increment it entirely. That is valid code, or you index this is a J and you have a J somewhere else, right? Like it's just that this code has more opportunities to be wrong, to make mistakes than if you just use a for each loop. So just use a for each loop. It's easier. It's less typing. It's more straightforward. It explains better what you're trying to do. There's a for each loop has pros, and by now it doesn't have cons anymore. Right? The cons were all reasons in the past, and so it used to be a trade-off. Now it's not a trade-off anymore. Now for each loop is strictly better. Second thing, this for each loop, or the previous loop, accesses the uppercase behaviors, which is the public read-only collection of our list. I would not recommend doing that because it's not technically wrong, but it's at least one more layer of indirection, right? Instead, you are inside the class. The behaviors are right there. So just go grab them. It's never wrong. It's never worse. Um, Most of the time it's the same, and sometimes it's better. So just do this. Because why could it be better? So one example why it could be better is if we had something like an enumerable here that we're exposing, then the for each loop might actually have to allocate an iterator and and that might allocate garbage. But if it's iterating directly over a list, then the list iterator, there's a specialization of a for each loop under the hood in the compiler um, that makes all of that go away, and it compiles directly to the for loop you see, right? So by changing, well, by removing type information through the getter here, because you want it to be read-only and it's only a collection and not a list, right? There's a potential that that now the for each loop will not be as fast anymore. And also there's a call here, and hopefully as read-only doesn't actually do anything. Like hopefully it doesn't make a copy or something crazy of the list, right? Hopefully it doesn't allocate a new list that points to the same backing array or something like that. Like hopefully it's just a facade wrapper kind of thing. But we don't really know that, and we don't really. It's unnecessary to go and research that if you just use the original list of behavior. So um, just use the original. And then what we're actually doing is we're just oh we're checking an instance ID. Oh, I was not expecting that. I mean, we have to find the behavior that has the same type, right? We were talking about how scriptable objects are. You can compare them by equality. So I was expecting to see just just this. But programmer chose to do this. So why is that? Oh, okay. Let's talk about that. What could possibly be the reason to write more code, make it more complicated than the the definitely shorter and easier, shorter to read, shorter to write, and, and also perfectly reasonable alternative that is just comparing the scriptable objects for equality. So I can basically only think of two reasons. One is maybe this is not exactly the same as this, and we want this. So maybe we have a case where the objects compare equal, but the instance IDs are not, and what we want is instance ID equality. Or there's a case where the objects do compare don't compare equal, but the instance IDs do not. And I'm not 100% sure whether either of those can be the case or not. I believe that they should be the same. I know that when Unity does the hot reloading, it the new object will get the same instance ID as the old object. So these instance IDs here, they are not the same as the pointer to the physical location in memory or something like that. Like you can absolutely have multiple instances with the same instance ID in Unity. Hopefully, though, they should live in an assembly that is being loaded and an assembly that is being unloaded, and then the assembly that is being unloaded gets actually unloaded, and that instance ID vanishes. So they should be unique. They should be unique, and there should only be one. And so comparing by instance ID should give you the result that you want. It should give you the same result as comparing just the object equality itself. Now, instance IDs are integers, and so this operator here is comparing to integers. That's all it does, and so it's very fast. This equality operator here is overloaded by Unity. It's comparing Unity objects and not just, I don't know, naked classes. So it's not doing a reference equals comparison. Reference equal comparisons are basically integer comparisons between the two pointers that point to the two memory locations of one of each left-hand side and right-hand side. And if they are the same pointer, then they must be the same thing, right? So it's, again, comparing pointers is an integer comparison. It's very fast. Reference equality is very, very fast. Unity's operator equals is not very fast because it checks whether the objects are destroyed, and if they are destroyed, then they don't compare equal to objects that are alive and those kind of things. So tends to be a little bit more complicated, tends to have a little bit more overhead. But that's about it. So the only difference I can see between these two is that this one is faster, or definitely not slower, than this one. So let's assume this was done for performance reasons. There's one more note before I go on a tangent here, which is this line will crash if one of those is null, right? If we pass a null here, then this dot get instance ID will crash with a null reference exception. If there is a behavior instance in these behavior instances that doesn't have a type, then this will crash right here with a null reference exception. And so this comparison will not crash. If one of those two is null, that's fine, right? The only time it would crash is if this here is null. So, okay, so not perfectly null safe, but it's definitely more null safe than the other one. So I'm putting that. So this is shorter, and this is more null safe, and this is less null safe, but potentially faster. Why would we choose one over the other? Well, all code is about change. All code is about maintenance. Maintenance dominates all other costs in software development. So the only reason to ever increase your maintenance burden, and this certainly increases your maintenance burden because now you have to worry about two more nulls, and you have to and the code is longer and more complicated. The only reason to ever do that would be if we have proven that there is a performance problem, and we have proven that the way to fix the performance problem is to do this particular change, and that involves using the profiler. right here, analysis profiler, running the game on target hardware in target hardware in release mode in the mode that we want to ship, and measuring whether we reach our target frame rate and how far we are off, and what is costly about it. And if we haven't done that, or we haven't done that on target hardware, or we don't know what our target frame rate is, or maybe we're just trying to write fast code as a principle, and it's not that much more work, and not just a little bit more complicated, and so we just do it like as precaution. Then that is the definition of premature optimization, which is the root of all evil, if you want to look that up. So I would, because of all these things, I would rather strongly advise to not go that way, to not optimize your code just yet. Just write it as simply and cleanly as possible, and when you're done with the implementation and it works, and you have debugged it and you have fixed all the bugs and stuff like that, then you can check whether if there's a performance problem and how to fix it, and then you will have a much better understanding of what the big hitting parts of your code are, where the really hot code paths are, where you need to spend your time optimizing it. And honestly, most of the rest of the code, it will be fine. It's not gonna matter that much. So there's certainly no need to optimize all the code. Okay, that was a tangent for a tiny little bit of code. The other thing, which is perhaps counterintuitive, so LinkU is a system that allows you to write very fast code, where you can do something like, okay, any in here where the behavior instance let's just call it BI for behavior instance. Oh, sorry. All right. Yeah. So instead, all of this code here is basically asking, in the behaviors collection, is there any entry where that entry's behavior SO field is matching what I pass in, right? In all of this collection, is there any entry? Is there any instance where this field is this? And right away you return true, otherwise return false. So it depends a little bit on how familiar you are with LinkU, and how familiar the rest of the team is with LinkU. I personally find LinkU quite nice because it allows you to express short ideas, like, okay, does this collection have any, or are all the entries in the collection this or that, rather succinctly, right? And so I would probably do this instead of all of this if this particular piece of code is not on the hot code path, because the LinkU is definitely slower. will definitely generate some garbage. We'll definitely allocate for the link queue itself, and then for the Lambda here for the capture. There's stuff going on. So it's performance-wise, it's a bad idea. But again, if we're talking about a function that is getting called, I don't know, like manually every couple minutes, every time, or maybe every time the user places an entity new into this world, which is really not so often. I mean, maybe you do that 100 times or something during one play session, or maybe if you build a big game like 1,000 times, and that's it, right? It's we're talking about tiny little pieces of memory, maybe 100 bytes or something. So 100 bytes times 1,000 times, that's still just 100K. That's not gonna make or break your game. That's not gonna kill your budget. That's not gonna trigger the garbage collector. That's the size of like one more texture in your game. It's really it's really nothing. So it might very well be completely reasonable to do this, to ship a game that uses LinkU in at runtime if the code path is just not being hit very often, right? But then again, it also depends on how familiar are you with LinkU, how familiar is your team with LinkU. If there's anyone who doesn't understand lambdas, or who doesn't understand SQL queries, and this is very similar to SQL, right? It can be daunting, and these things can become quite long when you put like selects and filters and wheres and first or defaults on them. So maybe don't do that. So I'm not gonna suggest that this was like a mistake, or I wouldn't call one of the two better or more advisable. It's mostly a style issue. So definitely not wrong, but a lot of code for something that's not that difficult. Speaking of things that are not that difficult, entity instance, entity runtime script. If it's a entity runtime script, what does runtime mean? Are we talking about? We're talking about the runtime in the sense that, okay, the app is running, or are we talking about the runtime in the sense that, okay, you've been in edit mode and now you're in play mode, so now this is runtime and this is not runtime. Does it? The original task, the original description of the problem did not mention the word runtime, so it did mention play mode and edit mode. So those are business logic terms, but runtime is not. And if runtime was important, I would have expected entity runtime instance or something. Like I would have expected runtime to show up in the class name. So I don't really see how the comment is making anything any better. I would just remove it and remove the unused usings. And then probably, I mean, this is very Java doc style, and it almost never. I have yet to meet my first Java doc that was actually useful and it told me something that I didn't know from the code. Some programmers even say you should configure your editor to you should configure the color of your comments to be bright red instead of pleasant green, so that they really stick out and hurt your eyes, because comments are a failure of code to explain itself. And while I do, that sounds a little bit extreme to me. I do see a value in comments if they explain to me the why, because the what I can see in the code, right? What the code is doing, I just read the code to figure that out. Why the code is doing what it's doing, that's often much more nebulous, right? Or bigger architectural types of documentation. Those those I would the explanations for those would not be in the code. I would either have to reverse engineer those by understanding the full architecture of the code, or I would have to read some comments. So I think comments are good for why and for higher level architecture explanations, but they are really bad for just describing the what. So okay, get behavior instance of the given type. There's no documentation on this. Returns the instance or null if the instance with a given type is not found. Like, yes, I mean, it's called get behavior, and it takes a behavior type and it returns that. What else would it be doing? What else could it possibly be doing? Kill this. And then the loop, make it a for each. They get an instance ID. Just compare the things themselves. So now we're down to code that looks extremely similar to has behavior. So what if we just get behavior? What if we just did that? No, we delete all this code. Because returning true or false is not any slower or faster than just returning the instance or null and doing a check on the instance or an additional check. I mean, yes, it's a little bit more work than if we just had our true or false, but this way it's a lot less code, right? It's just a lot less code. And again, if we wanted to go into the LINQ world, we could do, but this is a first or default here, return and behaviors. This would return the first one where that matches, or default, and the default for a class is not. So again, this is a one-liner instead of how many are those? 7 lines? And first or default is fairly easy to understand, even for beginners, I would say. Yeah. But again, I'm not gonna say that this for each code is wrong or anything. It's a more manual way to say that, the same thing. So then the other thing, so we get the behavior, and obviously it has the behavior if that behavior is non-null. I'm not sure if there is if we should have this function at all, if we already have this function, like if there's people who call this. Oh, there's nobody calling this. People who call this. Selection tool is calling this. Selection tool calling this might as well call get behavior, right? Like it's not different from a caller's perspective. And so the funny thing is that this compiles because, okay, now it returns a behavior or null, and Unity objects actually have an operator bool, so they are implicitly convertible to bool. and the comparison is whether or not it is null. So it will do exactly this. Like if the behavior is not null and not destroyed, then this will return true. Like this, the right hand side of this operator and will evaluate to true, and if it's destroyed or null, then it will equal to false. So I would say get rid of all of this. It's not necessary. It doesn't add more value. It doesn't even make it easier for the caller, because the caller doesn't have to do anything, right? If instead of the explicit comparison here, you use the implicit operator bool. I can't even like put it there. Like, okay, you like this implicitly converts as a unity object into a bool, right? So now if you're doing that, then it's the same as just not even saving it to a local variable. And if you're doing this now, then like the entire function is useless. So you're not making anything easier for the caller. So just get rid of the entire thing. There's no additional benefit. Um, and this brings me to another tangent. If there was an additional benefit, if this function actually did do something that was more complicated than this, but all it did in order to do that work was to delegate or to grab information that is publicly available, right? This here is public information. And so if this function, all it did was operate on public information, then it doesn't have to be a member function of the class. It could be, let me show you what I mean. It could be an extension. Let's assume that there was more than like more between here. Like it did more than just this stupid thing that it does right now. The trivial thing that it does right now. It's not stupid. It's just trivial, right? Um, all it does is fulfill its logic based on publicly available information, and and this is a subtle point, but entity instance extensions. The reason why I would put such a method into an extension then instead of into the class itself, and then move it to its own class, its own file, is because it reduces the surface area of the original class, right? It is now gone from the original class, while still providing the full convenience to the caller, who to the caller it looks like this has behavior function. It's still on the entity instance class, right? And 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 therefore it decouples the the maintenance burden of okay, maintaining this class and all its functions from the maintenance burden of maintaining all the convenience functions that callers somewhere else in the code might need. And by doing so, you have introduced one, like you have reduced the coupling in your system, which makes it easier to maintain forward. So over the years, I've gradually moved more and more towards classes that only expose the minimal amount of public interface to get the job done, and then anything else that callers might want to do that can be done with the publicly available information. That I put all that in extension methods, and not necessarily all in the same extension methods. Maybe you have some extensions that they are all for the entity instance, but maybe they have different. They cover different use cases, right? It just keeps the classes smaller, right? And now we're left with a really short and easy to understand class. Yeah, this looks fairly good. One last thing. I was talking about marking fields either serialized or explicitly non-serialized. Here we again have a case where, okay, this is not a field, but it has a backing field. It has the compiler will generate a backing field. The backing field itself will be private, and therefore it will not be serialized to the disk, but it will get serialized during hot reloading. So it might be advisable to slap a non-serialized on it for to prevent the hot reloading from doing funky stuff. Again, you don't want hot reloading in the first place, right? And technically your prefabs do get hot reloaded into the game when you enter play mode, but chances are your the prefabs we're talking about, which are these two here, they probably don't have a modification lingering from the last play mode in the ID field, because you're probably not going to modify the ID field of the prefab itself in play, right? You're gonna instantiate the prefab and then you're gonna modify the ID on the newly created instance. But just because you wouldn't do that, or it's not a good idea to do that, doesn't mean you can't. Like you can absolutely use prefabs and never instantiate them and use them essentially like scriptable objects. I mean, technically, scriptable objects are just prefabs that never get instantiated. Or, I mean, you can even instantiate scriptable objects. But anyway, you can absolutely put mono behavior onto a prefab and reference it from various parts in from other game objects and scripts, and then just set values to them on, just like you do with scriptable objects. It's literally the same thing. And if you do that, then you would end up in a situation where you could have some value, some non-zero value left in this field from the last play mode. And in that case, it would be in the prefab, right? And if you then instantiate the prefab, then you have a non-zero value in the ID field. And if you then don't call on instantiate, where you reset the ID like you should, and you. Oh, speaking of, we'll come back to this in a second. Then you could end up with like a wrong ID or something difficult to debug. And so, yeah, for the exact same reason, I tend to that I do what I did on the scriptable objects. I do this for mono behaviors as well. Just get rid of any hot reloading nonsense and be very explicit about what you want. Okay. On instantiate. instantiated, and then we call on instantiate on the new instance. Makes sense. Now, if this wasn't a mono behavior, but just a regular C class, and your flow is okay when you instantiate that C class, you also need to call on instantiate right after. Then the right way, or a better way to do that, would be well, if it's a C class, you would have an entity instance constructor, right? And you would pass the ID right in there, and then you would do this, and then you can even mark this just read only, and you don't have to, and you would get rid of all of this. And so by construction, the ID would be correct. But let's say for some reason you can't do that. For some reason you have to call the default constructor and then patch in the ID after the fact. So you can't do it in the constructor, but you also want to prevent programmers from forgetting to call on instantiate. What you can do then in that case is you have a create method, right, where you have a factory method, create instance. And in that you would new your entity instance, right? This is the default constructor where for some reason you're not allowed to pass in the ID directly, and then you fix up the ID, and then you return the instance. And because you do this, or even this way, you use a field constructor, field initializing constructor. Again, you get rid of that, and hopefully you can make the constructor private. At that point, right? So now you're disabling anyone from instantiating this thing directly, and you're forcing them to use the factory method instead. And the factory method makes sure that not only does it get instantiated, but also it gets initialized properly. And then the caller just gets the correct instance back. Now, this is not what's going on here, right? Because this is a Unity mono behavior that lives on a game object. You can't just do this. Can't just new entity instance. And instead, you would have to call instantiate on the prefab itself, and then do the things you want to do, right? But technically, you can. You have the prefab, right? Technically you can do something like this, right? Which is like a factory-ish method, where now instead of calling object instantiate, you would call instantiate on the. Oh, it's not called instantiated. I called it create instance. On the entity prefab itself, I mean the entity prefab being the entity instance within the entity prefab, and for some reason we also pass an entity root, so I think that's a transform. Right, pass a parent in there, and then this is where the actual instantiation happens, and then we fill in the ID, and then we end up with the fully initialized thing. Entity root, that is a transform. Yeah. What's the problem? Oh, the ID. Right. The ID. There. And then we don't need to do this anymore. We end up with a new instance that already has the right ID. That's kind of nice. And if we want to go further and also do the game object name thing, okay, why not throw that in as well? Name instance. There. Right. So you see the pattern where you can move things that belong to the initialization of the instance into a factory method that then does all those things. And because it is in the script itself, it has access to private variables, and you never have to expose a function which basically pokes a leak into your encapsulation. And the difference between this function and this being a public setter is that, okay, if it feels at least you had the chance to name it, right? At least you had the chance to communicate to other programmers and yourself that this function is probably supposed to be called on instantiation, and it's probably not supposed to be called at any other point in time during the lifetime of the entity instance. So you're really you're trying through human means to prevent errors, which is already much better than just having this public and being like, well, I know I'm only supposed to do this in the very beginning, or like put a comment on here being like, only call in the beginning. Right? That would be terrible. So so having a non-instantiate method is already way better than making it public, because by putting a name on it, at least you're communicating intent. But again, if you want to do if you want to go even further than that, you could even do it like this, where you do all your initialization in like a create instance or instantiate or whatever you call that method, right? It's a pattern that can come in handy. Now, all that said, in the other case, I was able to make the constructor private and therefore really forcing everyone to use this new code path, right? Instantiate. In the Unity case, I'm not able to prevent anyone from just calling instantiate. So this is not a solution to not a full solution to the problem, right? Someone could just call instantiate the thing in the traditional Unity way, never call create instance, and they would end up with an object that doesn't have an ID, and they can also there's no protection on changing the name whatsoever. So all of this can be bypassed, and because of that, I'm not gonna say that it's like the right way to do it or the only way to do it. I'm saying there are cases where this can be a useful pattern, and if you employ them, you need to make sure to communicate to your programmers that this is a thing in your code base, and that just calling instantiate like a naked instantiate, that's not what they should be doing. And maybe you make it plenty obvious that when you call the regular instantiate, that then, I don't know, some really important field is not initialized, and not having, and there's no way to initialize that field from the outside, and it's very, very central to the business logic. So if a programmer ever does it, they run into a problem right away, and they can right away tell that there is no setter for this field, and that should then put them on the path to think like, how can anyone ever instantiate this? How does it ever work, right? And then hopefully they find out, oh, there's a create instance method, and that's how this works. But again, this is an institutional thing. There's overhead associated. There's definitely a trade-off. It's not like one is clearly better than the other. Use it when it makes sense, and don't use it when it doesn't. I think that's enough for today. I'll see you in the next episode. Bye.